can do with the sound equipment we have been given. And Zoom was notoriously the hardest to hear around the room, so that's why we put the microphone closest to the Zoom speaker. I think the rest we can handle. So this is going to be the final event of the workshop. We're going to do like, let's say 45, 50 minutes panel discussion with our panelists who are there on the screen, and Antonio in person. Devi is also joining us. She is one of the co-organizers of the workshop, and she has also been working in interpretability. So I'm just going to put a bit of structure into the panel so that we are more efficient. We have Deepti, Devi, and I have prepared some topics before, and Deepti and I will be alternating through them. Now, if you have questions that are related to the topic that is currently discussed, please feel free to chime in. Deepti will be monitoring the Zoom chat, and I will be trying to moderate the questions here. Now, the biggest issue is for those of you who have been with us the whole day is that when you ask the question, we have to repeat it here because it's the sound is not that good. So let's try to have the short and concise questions, because I know I'm not going to be able to repeat the long ones. Okay, so with that, I'm actually I need to open the questions on my phone. I'm going to start with the first and the simplest question for all the panelists, which is we would like to for you to tell us a bit about yourself. So you all have worked on a wide array of machine learning topics over several years now. What is your general philosophy or take or view or excitement or concern around explainable AI? And what motivates you the most to work on problems pertaining to explainable AI? Also, if I'm speaking too fast, do let me know and I can try to correct myself. I guess we can start with Antonio.
Okay, so I don't know. I guess this is the microphone, no?
Yes.
So, okay.
I think Zoom people will hear you for sure. Yeah. It's more about the audience. So just let us know if there is issues with the sound.
Okay, so I'll keep it short. But for me, the reason to started working on explainable AI was really because at the beginning, we were so puzzled by the fact that it was working so well. And this was, the first AlexNet and so on. So that's when we started. We just wanted to know what was going on inside and try to make sense of what the units were doing. I think that at that time, the common belief was that everything was a distributed representation with no meaning whatsoever, which I think is, the right conclusion that you achieve if you work with MNIST, because that's the only thing that you can do inside the network is some distributed something. But we had higher level tasks, and the goal was really just to, we believed that there was something meaningful inside. That it was solving a complicated task. You couldn't do it, by having something very crazy and only making sense at the end. No, it had to be progressive. That was the motivation.
Devi, do you wanna?
Nope, I think we should go with the panelists.
Okay, so I'm gonna go in random order. So Yixin, do you want to go next?
Sure. Yeah, I came to think more about trustworthy and like explainable AI through worrying about outer distribution generalization and robustness, and we want to understand why things fail in some cases of outer distribution generalization, and is it even fixable, or should we just give up through that? And explainable AI give us way visibility into how hard the problem is and to what extent we fail or succeed in it.
Okay, Pradeep.
Yeah, similar to Yixin, I think one of the things I've started to get interested in is responsible AI, as we are calling it these days. So somehow the AI that we're using, the statistical AI that we're using these days is failing in various ways, and especially when we deploy them in high-stake settings. So part of the first step before we fix it is to understand why it's failing. So I think the remit of explainable AI is at least to shed guidance on why our current statistical AI is failing. Related to that, from my research standpoint, one of the things I'm interested in is how do we go beyond statistical AI? And one of the questions related to that is, how do you incorporate domain knowledge in the mind of humans? And this seems very related to explainable AI because we want to go from models to humans. If we can solve that, then we can go from humans to models, which we have always wanted to do in AI. So those are some of the reasons.
Thank you. Hima?
I think probably my journey into explainable AI has been similar to some of the other panelists. So I think as a grad student, I was working quite a bit on developing more and more complex deep learning models for NLP in the beginning, during the initial years of my grad school, and very quickly I just felt like we were not understanding what this model is doing. And instead, whenever there are errors, we are trying a bunch of, parameterizations and so on to just fix it without like really going into depth of like, what is the model doing? Why is it doing this? And so on. And that's how I organically got interested more in the deeper understanding of it. And then I happened to intern with Rich, who is also here, and Cynthia Rudin, I also worked with a bit. And, with both of their influence, I was pretty convinced that this is a very exciting research area and I should do more work in this.
And finally, Rich?
Yeah, so when I was a grad student back in the 90s, I trained a neural net on this pneumonia problem. And it turned out to be the most accurate model anybody could train on the data set. And they wanted to use it clinically. And I thought about it for a few seconds and said, we don't know how this neural net works. I think we should not use this clinically. And one of the reasons I was concerned was somebody else working with the same data had trained a rule-based system on it. And they had learned this funny rule that having asthma was good for you if you had pneumonia. And the doctors said, oh, that's probably a real statistic in the data, but it's dangerous for your model to predict that. You have to fix the model. And I thought, well, if it's a real statistic in the data, it's in my neural net. What else might be in the neural net if there are funny things like this? So it always bothered me as I worked in healthcare that the most accurate models were these black boxes that I didn't understand. And it always worried me about using them clinically. Finally, we had an idea, which was to take the ideas from Trevor Hastie and Rob Tibshirani at Stanford, these generalized additive models, and to sort of modernize them and see how accurate we could make them work. And thank God we're not using black box methods in healthcare, because every single data set we have ever worked on has unusual problems in it that would cause the predictions of the model to be risky for some classes of patients in those data sets. So we have never found a model that when trained on the data would be something we would be happy to release clinically without first understanding the model, finding a small number of problems, and then fixing those problems. It's, and the presentation earlier, which said that, a couple hundred models were trained on COVID and like 0 of them were found to be useful. This really does happen. And part of it is because if you can't understand the model, you don't actually realize what it's doing right and wrong. Yeah. And in medicine, there's a dictum: do no harm. You don't want a model to actually make predictions, which would actually harm certain classes of patients. So that was my motivation. Now, of course, the interpretability is useful for many more things. It's useful in finance. It's useful in debugging data sets. It's useful for all sorts. Once you've got glasses, you never want to go blind again. You always want to wear the glasses.
That sounds great. So one of the popular questions that gets asked is, there is always a trade-off between high performance models and building explainable or transparent models. What are your thoughts on addressing this trade-off, if there is a trade-off? I see Rich nodding, so you want to go first?
Sure. In tabular data sets, often there is no trade-off anymore. That is that there are glass box methods now which can achieve all the accuracy that you would achieve on those data sets with any other black box learning method. So that's great. And this came up at the end of Hima's talk, right? Somebody asked the question of, when should you be using glass box instead of trying to explain black box methods? And Hima's answer was right on the money, which is, if you can get all the accuracy and other requirements you need from a glass box method, you'd kind of be crazy to use a black box method and then try to explain it. I mean, go for a glass box methods. Glass box methods, there's no approximation to the explanation. They're very interpretable. They can give you usually both global and local explanation. Their explanations are perfectly accurate. They don't have any of the problems Hima was talking about, which is that different ways of even doing local explanation will give you different feature importances and things like that. Those problems all sort of go away with most glass box methods. Now, of course, there are times when you have to use black box methods for a variety of reasons. And in those situations, then you have to use black box explanation. But basically, if you're not going to lose any accuracy using a glass box method, you definitely should use the more interpretable method.
Yeah, I guess the tricky thing is when there is a difference in accuracy. So I guess for unstructured data that is specifically most likely to occur, images, text, and other audio and so on. So yeah, I think probably the best way forward is to try to get to glass box-ish methods, maybe in a kind of modular fashion. So maybe you can have a module that encapsulates all of the black boxness, and then sitting on top of that, you have glass box-ish things. And so if you can get something like that, so these neurosymbolic models would be one approach, but there could be other approaches as well. That may be like maybe a compromise.
Go ahead.
Yeah, just just to add on to that, I think in the cases where this kind of there was a real trade-off, I guess it really, or depending on what kind of high stakes settings it is, maybe there may be possibilities where we second think, I may not want to interpret anymore, but rather I want to be very careful about its uncertainty. Or say when we get explanations, say local explanations that can be very different around very different regions, that just means our model is very uncertain. So if we can make our model, our black box model, very honest about its true uncertainty, do we feel slightly more comfortable with using these? And how do we make them be truly honest about what they don't know and their instabilities and non-robustness? Yeah.
And just to add to that, is partly quiet because I think some of it was already covered in what I was answering earlier. But yeah, I think, to me, the cleanest way to look at it is your model is, sort of a function approximation of the ground truth data, and your explanation is sort of a function approximation of your model. So if you have an underlying model that's already interpretable, accurate according to your requirements, maybe there is no need to do another level of approximation, right? So that said, I think there is two points I want to note. One is, I think sometimes when people develop some of the inherently interpretable models, for example, there is ProtoPNet, which basically has a layer of prototypes that the model tries to learn, and then those prototypes are sort of construed as explanations, right? That may or may not be a human understandable explanation, depending on the context. So we may not always be able to, for example, if you need multiple different kinds of interpretations through an inherently interpretable model, how feasible is that? Is it better to just do something post hoc? I think that angle does not get explored often enough. So that's one thing to sort of keep in mind. And another thing that does not get talked about is there is so much work on adversarial attacks, or these kinds of post hoc explanation methods going wrong. There is not a whole lot of work when it comes to inherently interpretable model on that space. Maybe there is scope for, like, for example, when you're learning a prototype that is not really, so the risk of sometimes the model emitting certain explanations which may not necessarily sort of coincide with the predictions may also exist depending on how you're developing that inherently interpretable model. So it's important to watch out for that also. And one last point I'll make is, whenever this question comes up a lot, by the way, whenever I'm on panels and talks, and it is often asked as though it's politics or religion, so you have to pick a side. And I'm like, I do both. So there's, I mean, it depends on your requirements and applications, and both are interesting research problems. So I don't think this is politics or religion.
So, just to add something different, a little bit more controversial. So I think that to worry about the trade-off between performance and explainability maybe is not really useful, because the problem with performance, explainability is about making a system useful in practice. And the problem with performance is that you actually do not know what the performance is in practice, because you train it in a particular setting and then you're going to deploy this in a completely different setting. Who knows what the performance is? So, you cannot really worry too much about that. You might have a system you believe is working very well, and it might actually be a disaster in practice. So it's just, the explanation is just another output. It's giving you more information. It might actually help you to identify that the system is actually not working in practice. So the evaluation of the system is multidimensional, is complicated. And I think that the trade-off of performance and explainability forgets about the fact that, well, you actually cannot measure performance that easily. So anyway.
Yeah, I was actually going to ask a question very related to what you were saying, that if we could measure performance in reality, then would we still care about explanations even in these high stakes situations, right? So if we have a system that is making more accurate decisions than maybe the humans who are making those decisions right now, isn't do no harm translating to going with the system that performs better, even if it's not explainable?
I think that if you can actually prove, that's the performance that you have in a real setting, even in the healthcare setting, like I think that, you can go to a doctor that it will give you an explanation, but it's going to fail from time to time. Or you can go to another doctor that just tells you, okay, this is what we are going to do. I'm not going to justify myself. This is what you will do, and that's it. And you know that it almost get it right all the time. I think I can go to that doctor. However, I think that the problem is that this is not the reality. Like, the reality is that you cannot have that guarantee about the performance. And this is why you need explanations. You need this justification, because you really need to validate, the outcome. So I think that, being sure that the performance is a particular value and being able to give that guarantee, the problem is that that's not possible, because you will always be, you're not going to be a statistic, you're going to be a single individual, and you are going to belong to a particular population, and there will be a bias, for whatever. So you will really need that explanation to be sure that the output of the system applies to you. So I think that.
But I can still maybe say that we could specialize to a setting where Devi's question matters, like maybe a factory setting or some setting where we don't expect there to be domain shift, and everything is controlled, and we know what to measure. So in such a context, should we ask for explainability?
Yeah, no, I think that, if you have a setting where, it's a factory setting, it's perfectly controlled and so on, then probably explanations are not necessary in that case. No, you just want to have a system that performs as well as possible, and then postdoc explanations will be useful. will be good enough. You don't want to sacrifice anything on performance. I think it will depend on the application domain, but I don't know what the other panelists think.
Agree with it. I think it depends on the application domain, and I think the task and so on. Like for example, one of the things that did, there was a bunch of work in, I think somewhere in the last 2-3 years, but then it kind of lost a bit of steam, was explanations for like large scale recommender systems like Netflix or, Facebook friendship recommendation and so on. But I think people quickly realize that that may not be as valuable. So yeah, I think it depends on context and applications for sure, about whether explainability is really needed, or if we are okay with other guarantees on, say, robustness or accuracy in some of these aspects.
So one context in which I've seen some of these explanations used is in a human in the loop kind of systems, where you want to kind of combine this AI system with human feedback and so on and so forth. So in those contexts, I would say that even if we know exactly what we want to measure, it may still be helpful to have an explainable model, post hoc or intrinsic, because combined with humans, you can get a much better performance. Like for instance, humans can then point out, even if it has good performance, humans could point out some ways in which it can be improved. So that could be one reason where even if I know how to measure the performance, I may still want explainability.
So two comments. One is often we train a model because we hope to learn from the model what's important. So we do that a lot in ecology, and we do it a lot in healthcare. Even if we're not planning to use the predictions of the model, we're hoping the model will help us understand the statistics of the domain. So there are other uses of interpretability beyond just knowing if it's safe to trust the model's predictions or not. Also, this distinction that Hima brought up between a domain where there's no domain shift, where the future is going to look exactly like the training set and the test set. That's a really important distinction. So because the models are definitely rewarded for doing things from the training data that are crazy. And then if the test data is a random draw from the trained data or otherwise looks like the trained data, they're rewarded with extraordinarily high accuracy for doing things that are absolutely insane. And these are things like noticing that the patient is lying down versus standing up, stuff like that, which is very predictive. We've seen stuff where, a patient who's admitted to a hospital is usually higher risk than a patient who was not admitted to the hospital. And there are lots of features, including missing values, that will leak information about whether you were hospitalized or not. And all of a sudden, the model isn't paying any attention whatsoever to the health of the patient. It's just looking at the bill, or something like that to try to predict the health of the patient. So the models will do all sorts of crazy things, and they'll be rewarded with very high accuracy for doing these things. And if you can't understand the model, you don't realize that it's actually sort of cheating in a way that humans would not be willing to allow. So it's really important. If you know there's no domain shift, then hey, if the model's more accurate than the doctors, or boy, you'd sort of be crazy not to trust it. If you knew it really was more accurate in the real world. But then you'd still love to have explanations so that the humans can learn from the model, and then the human AI ecosystem hopefully moves forward and makes progress as rapidly as possible, because most of the AI systems aren't going to be sort of out there running the next generation experiments and things like that. These AI systems are still going to need humans for a few more years, to help them.
That's great. This is a great discussion. Let's move on to the next question, Filip.
Okay, so actually, before that question, that is going to be a nice segue. I want to say that I like how everybody connected performance with accuracy, and there was no discussion about the speed or the throughput. And I know that adding a post hoc explanation or implementing a glass box model destroys the throughput of the original simple black box model. So like a small part of the question is, we actually feel like throughput is not that important. These are the two important things. And another, like I'm moving away from that topic, saying there are few other challenges except the throughput that we faced when we started working on this topic, which was lack of data sets to benchmark to benchmark the explanations and to evaluate them, and the lack of evaluation metrics. So not only the post hoc explanations, but also these glass box models that are completely or inherently transparent. When they will produce explanations, what you want to prove is that to a human who is the user of those explanations make more sense or are helping with the task more than an actual post hoc explanation of a black box model. So to summarize the question is, what are the thoughts about the data sets that we currently have, especially in computer vision, because it's a XAI4CV workshop? Do you think we like them, or what can be done there? I'm going to let somebody volunteer.
So just to just check what the question was. There was a question, do we need data sets in the context of XAI4CV? Is that the question?
I mean, we can speak about benchmarks in general. I feel like, let's say you read two papers that are proposing some kind of post hoc explanation. It's very hard to actually compare both of them and to claim that one is better than the other. While if you take a model and your measure is a classification accuracy, that's a very simple thing to do. And I'm just trying to see, do we think this is a problem? Do we actually think we know how to evaluate explanations or how to claim that one explanation is better than the other? And if not, what is stopping us? Is it the lack of benchmarks, the lack of proper metrics, the lack of human in the loop tasks, or what is it?
No, I think definitely it's a lack of metrics. I think both my talk and Hima's talk were on some ways which we can objectively evaluate explanations. I think it's still in its infancy, I would say. We definitely need some objective ways to evaluate. And once we do, then I think it makes sense to talk about difficult benchmarks where we can then benchmark the performance. But right now we don't know how to evaluate. Yeah.
I can add a little bit to that. And I mean, agree. I think this is like a big question that we want to ask so that we really understand like which methods can be used in what kinds of applications, which methods are effective for what kinds of data sets and so on. And I think my 2 cents on this would be that there are probably more efforts that I've seen happening on this front in the last, I guess, 6-7 months or so. So especially from the perspective of like at least having some open source APIs out there. And the OpenXAI thing, which the archive submission that we have put out and the website is already live, the archive submission should be live in a couple of days. There we actually have leaderboards to compare performance. Of course, I'm not here claiming that the list of metrics we have there are exhaustive, but we have tried our best to incorporate a bunch of faithfulness metrics, some of which use, kind of if there is ground truth. For example, if you know the underlying model is a logistic regression or a linear regression, and there is, a clear ground truth, or we have constructed synthetic data sets where we can control what the ground truth looks like, and an accurate model on those data sets will have to learn that ground truth. So we have incorporated different kinds of metrics there, then different kinds of like stability or robustness metrics, also fairness metrics. So I think we are getting to a point where there is some critical mass, but obviously agree with Pradeep that we still have some way to go. And yeah, like I think, especially so our initial effort, version 1 was focusing on feature attribution methods and tabular data sets. Now we are working on a version 2, which is targeting vision data sets. And yeah, we are yes, that's a problem. And I think having like a one, kind of place where you have your data sets, you have your leaderboards, you have your APIs, just like people are able to run everything through there can be extremely helpful in the furthering of the field. I think we are getting there, but also agree that we are probably not fully there.
Hey, one thing that's probably worth bringing up is there's a difference between feature attribution for the global model and for local predictions coming from the model. For local predictions, it's pretty well defined. And you could expect that different methods would hopefully come up with similar answers. For global feature attribution, that's not the case. So in fact, some software I wrote had a dozen different metrics for global feature attribution. So metrics for global feature attribution, there is no one metric. There's no correct answer. There's many different definitions, and they often are anti-correlated with each other. So, one measure for global feature importance is, on average, how much does it contribute to the prediction? Like mean absolute value kind of contribution kind of thing. But another one that's completely different is, on average, if I were to remove that feature and just replace it with a missing value, how much would it harm the model to not have this feature? Those are correlated, those two. But there's another metric which we use in healthcare a lot, which is for any one patient, how big of a difference could it make to have this feature in the model? So it turns out healthcare has this long tail where there are a few very common illnesses. And for those common illnesses, things like heart disease, diabetes, pregnancy is common as well in hospitals. For those sorts of things, there's a small number of features that are critical for those things. And on average, they're incredibly important because they have an impact for those very common illnesses. But then there are very rare illnesses, and there are special features which are only relevant for those rare illnesses. On average, those features will never look important because they're useless for everything else except for those rare illnesses. And yet for the patient who has that rare illness, there's nothing more important than that feature. And that's a completely different way of talking about feature importance. On average, it's not very important. You could probably remove it from the model and you would only affect 0.0001% of the patients. But for those patients, it would be a disastrous thing to remove it. So it has a very big impact on some predictions. And anyway, I just thought it was very important to raise this issue after Hima's presentation, that global feature attribution is not well defined. There is no correct answer. You should not expect agreement among the many different ways of trying to measure feature importance. But like Hima's presentation, she focused on local feature attribution. And there, you really should expect a lot more agreement between these methods because it's a much better defined setting.
Another thing is that there is, for building explanations, I think this is not a single task. Not even a small set of tasks. It's like very diverse set of problems. And putting, I think benchmarks and metrics are very useful. They have clearly shown that generate a lot of progress in the field when applied right. But they also are dangerous, because they suddenly, you publish a paper and you need to use these metrics and this benchmark, and suddenly the only way is just by asking the same questions that everybody else is asking. So I worry a little bit about being to do this prematurely. I think it's okay to have some benchmarks if we kind of acknowledge that this is only evaluating a small slice of what building explanations is. I think that metrics and evaluation for general explanations will be very difficult because it's like, other fields like image generation, which is has a long story and with a lot of people working, and they still haven't figured it out how to measure the quality of an image that is generated by a model. The only way is by looking at it and it looks cool. Okay, that's basically it. And an explanation is a little bit like that too. Is depending on the application and depending what the purpose is, it's going to be, evaluating that will be a complicated thing. And I think that, we need some metrics, we need some benchmarks, but we need to be careful not to kill the field.
Yeah, I would definitely agree that it's basically, at least in the context of explanations, there isn't like a single thing. Even if we have objective metrics that there's a consensus on, like you said, we also need the subjective evaluations for explanations, definitely.
Yeah, I think I completely echo those 2 points. I think, as I was also saying earlier, I think first of all, the field is still evolving. So there's no way like something that is done today is going to be like the de facto standard. And that's why I think maintaining it, updating it, keeping up is critical. But also a lot of including Qantas, which somebody else also talked about, that library as well, and including some of the work we have been doing. None of these touch upon the interpretability aspect of it. They're mainly looking at correctness or faithfulness or like these kinds of measurable properties, not on the interpretability aspect of explanations. So that's a whole other, I guess, can of worms, honestly. Yeah.
Yeah, that makes a lot of sense. I mean, I think that's a great segue into one of the questions Devi had brought up earlier. That ties back to the subjectivity and human studies that are required for evaluating explanations. Some make an argument that humans themselves are particularly bad at providing faithful explanations for why they did what they did. So how do we deal with that if we want to use human studies as one way for evaluating our models?
Well, don't trust humans.
Yeah, I mean, but we shouldn't benchmark AI models with what humans do, I guess. So would be the short answer. Yeah, there have been these fascinating neuroscience experiments where if you cut I forget what it's called, but the connection between the two hemispheres of the brain, then there's
corpus callosum.
Corpus callosum, then one part is responsible for generating explanations effectively, the analytical side, and the other part could be observing. And people come up with fantastical explanations for if you have essentially a board. Anyway, without getting too much into the details. So humans definitely do generate explanations and rationalizations and so on. But we should expect more from AI systems. I mean, we have people who have a lot more care in not rationalizing. So I think we should expect the same for AI systems. But it's a worry in some sense where if you have highly capable AI systems that generate explanations, that doesn't automatically mean that we can trust those explanations, basically, similar to humans.
Yixin, what are your thoughts?
Yeah, I mean, I agree with all of what you're saying. And I think one additional point that may be worth considering is ask, like, what do we use these interpretation and explanations for? Like, if we wanted to use them for better human AI collaboration, then there could be a measurable outcome. Say, if I have a model produce certain explanation, and does it prompt a human to build a better model or better write a better essay or anything? Like, we could, if we really care about specific downstream outcomes of these explanations, then there could potentially be more objective measurable outcomes that we may care about. Of course, there'll be other cases where we just care about explanations by itself. Then that's a whole subject by itself to understand what do we even mean by a better explanation.
I think, by the way, one reason why we want explanations from our AI systems is humans have a lot of common shared experience, right? And they grew up, they know common sense, they know how the world works, they know what it means for a person to live or die. They understand sort of all of those things. And if you think about what we ask our machine learning systems to do, it's really pretty remarkable, right? We take a data set, it's pretty large, but we hand that data set, which doesn't have any of this other information in it, and we give it to a model that basically starts from random initial conditions or something, and we expect it to suddenly like be very performant and to not do things that we view as crazy, like cheating, by noticing that the patient's lying on a bed versus standing up, or looking at the buttons that the doctor pressed on the tool as opposed to looking at the image itself. Well, we just expect the system to somehow magically get it right, and we really understand that a human is not likely, unless they're trying to be intentionally malicious, they're not likely to make any of those kinds of mistakes. They really have an idea of what are the things they should be attending to. Like if they're doing a tumor diagnosis, that they really should be looking at the tumor, not at other things. But our AI systems don't understand that. They're idiot savants in some way. And because of that, they're going to make all sorts of crazy mistakes we would never have anticipated. And that's why the explanation, both global to vet the model and local to understand its predictions, can be so important, so that we have an idea that our AI system isn't being too idio in its idiot savantness. Like we want it to be, savant when it can be, but not too idio. And yet, if you're only learning from one data set, man, it's so easy to learn things that are just truly unexpected, let's say. And humans, when they see these things, are like, oh, they hit themselves in the head. Oh, I should have realized that's going to be in the data. And of course, it's going to learn that. And of course, that's completely irrelevant to the problem, but it's just a bias in how we collected the data, processed the data, things like that.
Okay, so moving on to the next topic, the nature of explanations, that is how detailed and specific they should be, differ based on the target audience. For example, a layperson versus a researcher versus data scientist, regulator, expert, etc. Or do we think that the explanation should be generic? What are your current thoughts on accounting for that in your algorithm design?
Will we start with Antonio? This has been quite.
What?
She suggested that we start with you.
Oh, start with me. Okay. No, I think it should depend on the audience. I think that the goal of the explanation is to provide information to the audience. So it should be conditional on the audience, and it's not the same thing. A person that already knows how the system works very well versus a person that is going to decide whether the patient or the client, or it's not the same thing, the person using the system than a regulator. I mean, it's just different audiences, and the explanation should be different. So that that probably that's another reason why benchmarks are delicate.
I mean, in your case, some of the stuff that you presented, the explanations weren't even for a human audience, right? You kind of took those interpretable nodes and mapped it to language to give you annotations for a GAN to then generate a bunch of data with those annotations. And so there isn't even a human audience there.
Yeah, the type of explanations that we've been working on are more for kind of debugging purposes. I think the audience is researchers, the kind of things that we have been doing. Where you just try to see if now you can intervene on the network to make it do other things and so on, but it's not meant to satisfy what a person, the questions that a person will have about why is this image being classified that way or this other way, or whatever the task is. It's not going to be satisfying for them.
Yeah, so I mean, my take on this is I think this aspect is both like a boon and a bane for explainability or interpretability literature. I say that because I think, yes, while there are several use cases or applications that we might want to provide explanations for, so there is a reason to cater to different kinds of audiences and, users, applications, all kinds of things. So that's one aspect of it. So I think the requirements call for it. But at the same time, I also think there are some aspects that we can abstract out, and that's how create some kind of generic classes that we could study, analyze, understand how they behave. And I also want to make a subtle distinction between two aspects. So one is some kind of correctness aspect, or some kind of, think about robustness or correctness, versus like, is this explanation actually useful to human users, right? I think the third aspect is probably likely going to be a lot more driven by an application, an end user, and audience. But I think there is some merit to sort of, pooling these things, characterizing them, and trying to understand their correctness in a slightly more abstract way. So that's how I think about it. So both are important. An explanation that is not correct is useless, even if people are able to understand it. In fact, it's misleading. An explanation that is absolutely perfect, but nobody can make any sense out of it, and it's not usable, is also useless. But that requires a lot more sort of testing within a specific domain with the end users, with an application. Whereas I think for the correctness part, potentially we can abstract out things and then come up with classes of things that we could even theoretically analyze, right? Like if we are coming up with one explanation for each application, then we can't even analyze its theoretical properties, which could actually be helpful, so that we don't do 100 experiments to validate or invalidate the correctness of something proposed. So I think there is something to abstract out, I feel. And then there is also like the usability aspect, which needs to be tested with a specific audience and a specific application. So there are like two sides to that. At least that's my 2 cents.
I think, in terms of different audiences, I think ultimately one way in which we can formalize that is by having different utility functions for our explanation. So right now, most of the utility functions are just based on simple fidelity to the model, which is helpful for, I guess, more machine learning users so basically that's the audience. But if you think about other audiences, so the utility function could be different. So we had a paper a while back where, so one of the explanations that a lot of people were using even before the XAI field was partial dependence plots, which let's just think of that as some visualization. But there are many, many visualizations you can do. So the question then which we looked at was, which visualizations should we show to the user based on the user? And so if you can abstract that out as some utility function that they care about, for instance, it could be related to fairness, it could be related to maybe some assertions or some properties they want the model to satisfy. Then based on that, those should be the explanations that should be provided. I think, yeah, it's what you asked is a very, very important question. I think that we need to formalize more. The XAI field needs to more formalization there. This again goes to the objective evaluation, objective metrics. So in machine learning and computer vision and so on, we take loss functions for granted. And that's what we use to train models. So to train explanations, we need, again, these loss functions or utility functions. But that would be the way to proceed, basically.
It's an interesting question for those of us who work in glass box learning, and that we're not concerned so much about fidelity, the correctness of the explanation, because the methods are usually inherently explainable, and therefore you get a sort of perfect explanation. But that doesn't mean that the model can't be overly complex or uninterpretable for some users or not satisfy their needs. So we do think about having to provide explanations for the explanations. Sometimes what a user wants is just sort of some simple what if kind of thing, like what would I have to do to qualify for the loan, or what's the main reason why, whatever. And you don't want to give them back 100 graphs and say, oh, here's the explanation for why you're high risk or low risk. You just want to say, oh, for you, it really comes down to these two key factors. So right away, that's a tremendous simplification. And I think of it kind of as regularization in explanation space, where you need to do different kinds of regularization to make the explanation a good impedance match to the user. And sometimes they're not interested in the detail of the prediction. They're just interested in what do they have to do. Sometimes they're really interested in the detailed why. sometimes we even talk about taking our detailed graphs, which show lots of fine detail on it, and almost making like cartoon versions of them so that they're just simpler and easier for people who don't need the detail to sort of understand, oh, risk is going up with age, in this sort of general way, without seeing the detail, like, oh, there's a jump at retirement and there's an affected age 85 and a weird affected age 100. They don't need to see that level of detail. So it's a really fascinating question, even for those of us who work in glass box, where fidelity is not an issue, but still making the explanation match the end user is very, very important.
That makes a lot of sense. So final question before we close the panel discussion. So there's no argument that explainable models are very critical for applications such as healthcare, finance, and self-driving, as we've discussed. But how crucial is explainability in other less critical domains like ad recommendations or product recommendation systems? Or do you think it's enough if the bulk of the research happens only on building XAI tools for these more critical domains?
Let me just give a very quick answer, which is we often find that there are problems with data that are unexpected. And then these things come to light when we see the interpretable model trained on that data. So even if your goal is just to train an accurate model where in the end you won't care at all about the explanation because it's not, a mission critical domain, it turns out just being a data scientist who wants to train a more accurate model, explanation is really, really valuable to you. It's much easier to do engineering, and build a bridge when you can see as opposed to when you're blind. And an explanation sort of gives data scientists that.
Yeah, actually, sorry.
No, please go ahead.
Sure, go. Yeah, I just wanted to also reinforce that. I think that explanations is, if anything, at least as a debugging tool, is super important. I think that, a lot of students are used to train systems by just looking at the loss and seeing that it goes down. And then you ask them, well, but show me one image with a classification result. But they don't even have the script to do the plot. They didn't care because still the laws haven't gone down enough, or it's unbelievable. And so I think that explanations is if anything is just a way of looking at the pixels again, looking at what is the system doing, and the loss. Look at the loss later. Who cares about the loss? Let's look at the what is the system actually doing. And I'm talking about non-critical applications at all. You are just developing something in the lab. It's not going to be used by anyone. But at least, the reader of the papers will be your consumers, and you need to understand what is going on.
Yeah, I would agree with both of those points. So basically, one of the points was that we don't know the exact evaluation. So in that case, even if it's not mission critical, I just want to classify cats versus dogs or something. And so even in that case, if I don't know how to evaluate exactly, then explanations can be helpful. And the other is that we can, even if you do know how to evaluate things, like the loss function is very clear, you can use these to improve your model. You can classify cats as dogs much, much better. And right now, just looking at the loss doesn't give us any insight into how to improve. So both of those points, I think, even in non-high stakes settings, make sense.
Yeah. And beyond debugging, I feel like there is also not enough studies there are not enough studies to explore the utility of explanations beyond these settings. Of course, debugging, I think everyone is echoing that can be pretty useful, irrespective of what the setting is, like whether it's high stakes or not, people can still use explanations for debugging. But there also, I think, what kinds of explanations will probably play a role. For example, things like I think Percy and one of his students had some work on influence functions and how to map a point in test data back to points in training data. So maybe those could be more useful for debugging. Again, it depends on the context and the training of the person using it and so on. But that said, beyond that, it's also interesting to see, like, if somebody's shown an ad and then they're told, here is why we are recommending you this ad. Would that improve user engagement? Would that actually make a person stay on the page longer, engage with things there, come to the portal more often? I honestly think that knowledge or that understanding is missing. So it would be very hard to say that we can dismiss other use cases. Yeah, so that's.
Okay, we are getting very late. There was one question from the audience. I'm going to ask that quickly and try to get an opinion of all of you and close the panel session and the workshop. So I'm actually going to rephrase the question, but basically what I wanted to ask is, what would you say to the new XAI researcher? Where should they start? And then the question for the audience that I think fits well here is, what could be the next major innovation in terms of interpretability?
These are not questions that have short answers.
Well, I can give you a short answer. Trevor Darrell said the answer to better explanation of deep learning is more deep learning. And I thought that was a cute and possibly correct answer for some domains.
I would say maybe taking things in a more, changing the classes of models a little bit itself might be the way to go, as in using, so to me, it seems like there is this loop between existing models using explanations and somehow taking explanations and improving a class of models itself. So that to me would be the exciting thing, neurosymbolic models. And the other thing that was brought up was also targeting explanations to particular stakeholders. So these.
Yeah, I share a similar view. Where I see how they can help us better as they come up, create out of distribution, like testing data sets. I mean, there are a million ways things can be out of distribution. There's only one way things can be in distribution. So like having explanations will help us construct these test data sets or debug models, or improve trust from users in building a better pipeline, cooperative pipeline between humans and AI.
I think one thing I would add is, especially for folks who are new to the field, I think one of the advantages of being, or rather wanting to start in a field like this, is you can look at existing research and question the assumptions that it is making and come up with like fresh perspectives and like, clean way of looking at these things and say, oh, maybe this is how we should do this, and not like how these past 50 papers are approaching it. So I actually think that beginners have an advantage in terms of like getting, because this field is also nascent and it's not like completely fully established. So I think some good, especially for beginners, a good way to think about it is, are these 10 algorithms that were proposed to generate this kind of stuff, are they the way to look at it, or are they making assumptions that are fundamentally incorrect, which should be rethought, right? So I think questioning the basic assumptions of methods, I feel, is like one very big thing that could yield a lot of interesting work and important work in this area. And beyond that, I think so I feel like there is a bunch of kind of disjoint work in this area, whether it's in vision, whether it is on the fundamental methods, whether it is in theory that's also coming up of late. So I think kind of characterizing and putting all that together, establishing connections, see how things differ, how things are similar, could be very interesting and useful in terms of the furthering of the field. So I'll stop there.
Okay, thank you all. Let me then do very quickly the closing remarks for the entire workshop. There was this, so first, let me thank the speakers, the panelists who stayed here until this late throughout the day. All other speakers, thank you for the in-person audience. This was great, very refreshing after a long time having in-person conference. Thank you for the virtual attendees on Zoom who were also involved, asked a lot of questions. I mean, the whole experience was great for me, and I hope it was great for everybody else. Now, the QR code and the link that I was showing throughout the whole day has a lot of these information, but like posters and stuff like that. But I will also, throughout the week, depending on what organizers allow or not, try to add recorded talks and more materials from the speakers and the spotlight sessions. So do keep an eye on this website, and thank you again. Deepti, do you want to say a few words?
No, just echoing. Thank you, everyone. I know everyone is in a very different time zone, so it's very late for some of you. Thanks for the great panel discussions, for the great talks. We really thoroughly enjoyed organizing this and attending every talk. See you all in next CVPR.
Hey, and thanks to the organizers for organizing the workshop.
You're welcome.
Yes, this was super fun. Thank you.
Thanks for organizing. Great to see you all.
Thank you.